want to talk about idea how we can use deepfakes to give better voices to people. So first I want to go over some terminology. There's something called an AAC, which is Augmentative Alternative Communication. It's used by many people that have difficulties with their mouth or autistic or verbalizing. It's an alternative communication tool for mouth words. Mouth words are words spoken with the mouth. There are many different versions of it. Some of them are primitive, so-called, with technology, and they can be exchanging pictures on flashcards, sign language. They can be using a whiteboard. They're not always the best because they can be bulky if you have a lot of different cards or other devices. And then there are the fancy electronic ones. The fanciest electronic ones that you might have ever seen are the ones like used by Stephen Hawking that look at eye movement, and now some people are working on ones that use brain scans. But there's ones that you simply type stuff, and the type stuff will be pronounced, or hit pictures, and many different versions. But a problem with it is that there's a limited range of voices, and you might not be able to choose your voice. And the voice is very important to a person because it can express who they are, their identity. It can also, some voices are clear to some people than other ones, depending on where you grow up, what accent's most clear or not. So it can also change up the voice for like clarity, but also it can be a way of expressing yourself. Maybe you want a high-pitched voice because you're squealing with happiness. Maybe you want a low commanding voice, or maybe you're copying a voice from a movie and because that movie spoke to you in that particular line, which is also something very common in the autistic community, something called scripting. And scripting is done by a bunch of people. I don't do it that much because I don't have the memory for it, the verbal memory for it. But when instead of using your own words, you repeat phrases or words from any source, and sometimes you copy the voice or the mannerisms. And it's not, some people might think it's a lazy way of communicating, but it isn't really. It's that script can mean that you have more brain left over to do other things, so you don't have to think about your words as much. And it can also convey emotions and memories that link to where you got the script originally from. Maybe it was a movie that really spoke to you, and you like that voice because it tells a powerful character, or maybe it's something sad, so it says a sad one. And it can be really important. And that's why scripting is like not less a form. If you think about it, a lot of people do use quotes, oftentimes from religious people to people that try and pretend they're intelligent by quoting the textbook when maybe they're not really. It's fine if they do it, but it's not a sign of intelligence. And side note is I had a teacher that was from India that he said to win debates when he came to America as a child, he would quote his friends and then pretend they were famous people in debates. This is so funny side notes how quotes can make you seem smart even if they're not. The thing about scripting that people look down upon it is that it's not as famous movies and stuff, so people just don't see it as the same, which is silly. But back to the topic. So there's something called deepfakes. Deepfakes are a technology that we can take a person picture and replace the face with a face of someone else, but they're smiling, have the same emotions, and even do that in a movie with a moving like the person. To show you an example of this deepfakes on the internet, the target is the original person. So the target is the person they're trying to mimic, and this is the source, and they're turning the source into the target over and over again, and they're seeing if they can do it. And then looking at different versions of deepfake. So all these are different versions. Now what they're hoping to do is get the source, the target, to have the same facial expression. The source to look like the target, but with their facial expression or there. It's not perfect, as you can see. I mean, it seems to have a little bit of problem with teeth, especially, which makes sense for the most varied. But there's many different types of deep fakes out there. these are famous people generated with deepfakes out of a target, and you can see it's a little off. But the technology is really rapidly progressing, and it's kind of scary how fast it's progressing. But to make deepfakes, and these are all AI technologies, it's very complicated because pixels are really complicated sets of data. No pixel alone is important. Every pixel is important relative to everyone else. If I dim the whole picture, you can still tell it's a face usually. If I brighten it up, you can still tell it's a face and who it is from. If I put on red light, green light, or different lighting, you can still tell it's kind of the same person. If I put it upside down, you can still probably tell it, sideways or something like that. It's a lot of manipulation because it's not every one thing, and it's not even the pixel just next to it. It's a whole thing together you have to take into account. It's also a lot of data. If you look at movies, there can be a typical movie in an hour length is gigabytes of data. If you look at an audio file of similar length, it can be kilobytes to megabytes, and they can be perfectly recognizable. So audio files can be 1,000 to 1,000,000 times smaller. And in audio files, it's not, there is some important stuff with how stuff is relative to one another, but it's not as important. And it's more like, here's your data and it's clear. If you make it higher, it sounds different. It's not the same thing as much. So with audio, the data is less complex. There's a lot less data. And it's also easier to encode. You don't have to encode red, green, and blue. It's also even easier with time series because there's something called Fourier transform, which can collapse data into simple streams of information that's more easily analyzed. You can do it on pixels, we use it on pixels, but it doesn't work as well as data audio where it works great. What I'm getting at is we could more easily make a deepfake for audio. Now, if we had a deepfake for audio, we could use it for AAC devices and make an AAC device mimic the voice of whoever we want, and then a person could program it to have their own unique voice. We also don't need as much data to do it. In another way, for all these deepfakes I'm showing here, they train on thousands of images to millions in the most extreme case. And to make a good picture of a person, you need a lot of pictures of that one person. Use a lot of pictures of people in general to first train to get a general idea about faces, facial features, like where the eyes are, the nose are, everything, and sort of different types of faces. Like, what do you expect people with curly hair, what do you expect them more to look like? Just a general idea. It's not perfect, but it gives you a general framework. So then when you train it more specifically with one image, it gets a better idea, like when it trains with one person. But the more you train it with one person, the better it is. Voices do not vary as much as faces, and also quality. So you can make a better inference from a small audio sample, what it would sound like if they're talking other words. Now, the bigger audio sample you have from a person, the better. So the more different words they're saying, everything. Because maybe they say one word weird. Maybe they say two words weird. And the example would be, I know some of my family members learn different things in different languages, so they say different words with different accents, or they say certain words in certain languages. But for the most part, it's simpler and you can infer it. Now, when you have an inference of it, I can only just say like a couple words, and he says, oh, I have a high-pitched southern accent. I have a high-pitched voice and I have a southern accent. Or a low-pitched voice and a Canadian accent. This would allow for greatly people to train it and modify the voices or store them. You could even make it one that device, if you put tags on the people's voices, you could slowly train the model so it could say like, I want a voice with a southern accent with a low voice, or I want a Hispanic accent or with this voice. Just train it and then modify with tags with each of the different types of voices, and you can learn little subset categories, which actually would even improve the training, because having multiple tags improves training, because it learns like, it uses the same neural network to learn big features too, which makes it work a little better. The other thing that it could do is, it could also get rid of accents for people that have trouble understanding other people. So the first is that if you have auditory difficulties processing, it could translate someone into a clearer speech pattern. An interesting side fact about that is newscasters actually all train with a specific voice, especially meteorologists, which is why all of them sound very similar. There are exceptions, especially in local news. And that voice is considered the most clear voice out of them all. I think it's some Midwestern accent. Now, they sometimes break voice and there's a bunch of exceptions, but it's true that certain accents are slightly more cleared overall to more people. Also, there's individual cases, like if you grew up in an area, the accent of that area is probably clearer to you than most other accents. Well, thank you very much. I hope you found this interesting. Goodbye. Please like and subscribe. I'm trying to reach 1,000 subscribers within a year, which is a really hard goal, and 4,000 watch hours. With your help, I can do it. And if you have any ideas for future videos, comments, or questions, or anything, just leave them in the comment section below. Thank you. Goodbye again.